Hello and welcome to Nikolai's genetics lessons, and today I have prepared another probability problem for you. And here's a problem. From a group of 10 students, 7 girls and 3 boys, a teacher must choose 2 girls and 2 boys to represent the book reports. How many different arrangements of students in order are possible? And in order to solve this type of problems, you have to know difference between combinations and permutations. And today I'm going to solve this problem and show you a solution without application of any formulas, so you would understand how to solve this problem in most basic way, using common sense and logic. And of course, later, if you will learn how to apply different formulas, it still would be much easier for you to understand when you would have this basic knowledge. So let me first show you these two pictures. And looking at these two pictures, it would be easy to understand the difference between combinations and permutations. For example, salad here on the left is good representation of combinations. So we combine different ingredients here in order to make this salad. If you choose different ingredients, you are going to get different salad, even if you would choose just one different ingredient. But take a look at this log, which usually we call combination log. But in reality, we should call it permutation log, because it's not just enough for us to know that, for example, just 4 numbers we need to know in order to open this log, but we also need to know exact order of those 4 numbers. And you cannot open this log, for example, if you know that it is 1, 2, 3, and 4, which opens this log. You also need to know in which order these numbers goes. Again, just memorize this picture, that salad represent combinations and log represent permutations. Now let's return to our problem. So let's read again. From a group of 10 students, 7 girls, so we have 7 girls, and 3 boys, a teacher must choose 2 girls and 2 boys. So we need to choose first 2 girls out of 7 girls. How many different unique combinations we can get? And again, please pay attention to this word in order. So order matters when we solve this problem. But first, let's find number of combinations, how we can choose 2 girls out of 7 girls. And I'm going to use some method familiar for those of you who study genetics, which we call Punnett square. And let's pretend, for example, this is going to be girls. So girls. And let's say that girls has names as 1, 2, 3, 4, 5, 6, 7. So this is going to be girls' names. So girl number, not number, just girl 1, 2, 3, 4, 5, 6, and 7. And let's build simple Punnett square. So 1, 2, 3, 4, 5, 6, and 7. So our Punnett square is going to be 7 by 7, and we are going to find combinations of this variance, how we can combine these girls in pairs, and 7 by 7 would give us 49 cells. But that doesn't mean that we are going to get 49 combinations. Again, we are looking for unique combinations. And now let's count how many unique combinations we are going to get. For example, take a look. Here we are going to get 1 and 1. This is not 11. This is girl by the name 1 and girl by the name 1. Again, this is unique individual. You may think about this individual as, for example, Lena or Natalia, for example. And from a group of 7 people, 7 girls, we cannot choose 2 Natalias because each individual is unique. So this combination is not possible. And of course, another combination is not possible: 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6, 7 and 7. These combinations, as you see, are not possible. Out of group 7 girls, we cannot choose the same person twice. Now let's take a look what different combinations we can get choosing 2 people out of 7. For example, it can be girl 2 and 1, 3 and 1. This is not 31 and not 21. Girl 4 and 1, 5 and 1, 6 and 1, 7 and 1. Another combination can be girl 3 and 2, 4 and 2, 5 and 2, 6 and 2, and 7 and 2. Another variant would be 4 and 3, 5 and 3, 6 and 3, 7 and 3, 5 and 4, and 6 and 4. Next, 7 and 4, and 6 and 5, and 7 and 5. And the last would be 7 and 6. And again, here we are going to get the same combinations, just in different order. Let me show a couple. For example, in this cell we are going to get 1 and 2. And we already have a combination of girl 2 and 1, and 1 and 2 would be here. But again, take a look, order does matter. So we also have to count all these variants, but I'm not going to do it right now. We will do it later. So for now, all these variants also doesn't matter. What matters is number of these unique combinations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21 unique combinations we can get. How we can choose 2 girls out of 7 girls. So 21 unique combination. Now let's return to our problem. We also told that we have to choose 2 boys out of 3 boys. So we have to choose 2 boys out of 3 boys. Again, let's say we have a group of boys here, and names of the boys would be 8, 9, and 10. And again, we are going to build another Punnett square, so 8, 9, and 10. So here's another Punnett square. This time it's going to be 3 by 3, and we are going to get 9 cells. And the same rules apply, so 8 and 8, 9 and 9, 10 and 10 we cannot combine. So we just have to cross out this variance. For example, if we have John, Boris, and Ivan, we cannot choose 2 Ivans out of these 3 people. We cannot choose 2 Boris or 2 Johns. This is obvious. So what would be unique combinations would be 9 and 8, would be 10 and 8, and another unique combination would be 10 and 9. Again, 10 here stands for just one person. This is not 2 numbers that represent 2 people. So, and again, we also can cross out all these combinations because we are going to get repetition here. And again, how many unique combinations we have here? 1, 2, 3. So there are 3 ways how we can choose 2 boys out of 3 boys. And again, right now we are not interested in the order, because if order is important, then we would have 6 such combinations. But we're going to account for this possibility later. And take a look. So what our next step would be, so we have 21 variants how we can choose 2 girls, and 3 variants how we can choose 2 boys. And it is obvious we have to use product rule. We have to multiply these independent probabilities. So this would be our first step. We have found all possible combinations of boys and girls. But now we have to use a rule of permutation. So when we found all the unique combinations, think about this like a salad. We have found all the ingredients, but in combinations, order, it doesn't matter. But according to our problem, take a look, we have to find in order. So this gives us a new level of complexity for this problem. Now we have to use rule of permutations. And take a look what our next step would be. So we have to choose 4 people out of 10. 2 have to be girls and 2 have to be boys. And boys and girls can go in different order. For example, first one can be a girl, then a boy, then a boy and a girl. More than that, girls are different people, so the first girl is not the same as the last girl, and the second boy is not the same as the third boy. So this B is different from this B, and this G is different from this G. And how many different combinations or permutations we can get with 2 girls and 2 boys. And here what we are going to get, for example, if we have 4 people, first place can be taken by any of these people. So by any of these people, so we would have 4 variants. So we would have 4 variants. What can be the first person? It can be, for example, this girl, or this boy, or this boy, or this girl. So 4 variants. But how many variants we have who can take second place? And because we already have one person who took the first place, we now left with 3 places. So 3 variants are possible here. And for example, this is going to be this boy. Now we have 2 variants. This can be whether this boy or this girl who can take this place. So we have 2 variants here. And now we don't have any choice, only 1 variant here. So, in other words, in order to find all these permutations, we have to multiply all these numbers. And probably some of you have noticed that this is factorial 4. Again, factorial 4 would equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So, how many combinations we would have? We are going to have 4 multiplied by 3, 12 multiplied by 2 would be 24. 24 combinations or 24 permutations. So 21 unique combinations of girls multiplied by 3 unique combinations of boys and multiplied by 24 permutations. How we can arrange these unique combinations of boys and girls, and we have 24 such permutations. So what we are going to get here, we are going to get 1512. Again, pay attention that this is going to be a combination, different number of combinations of boys and girls, 2 girls and 2 boys. So 21 multiplied by 3 going to be 63 different unique sets. We can say sets of boys and girls. But if we will start also think about how we can arrange them, every set out of 63 would have unique variants how we can arrange those people. And this would bring us new level of complexity, and we will have more variants how we can arrange people, and the answer would be 1512. Now let's compare with our answers, and as you see, this is answer D. So again, today we have learned what is the combinations, what is the permutations, and as I said earlier, it is easier to keep our calculations separate, combinations from permutations. For example, again, take a look. Here we have 2 and 1, and here we have 1 and 2. So this is unique combinations, but if we will start to account for these combinations, this is going to be permutation. So it is easier to just keep a track of unique combinations, multiply by unique combinations, and then multiply by number of unique permutations. But if we'll also take account of these numbers here, we are going to get a mix of the combination and permutations. And it is easier to make a mistake if you will do calculations of the mixed numbers. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day, and see you in the next video. Goodbye.